Alright, so hello everyone. Lecture 2 Maths. It's time that we can start exercise with one basic. We've covered this basic in previous standards, but I would still like to just go through it. For example, if I have something like this, 5 by 8 plus 3 by 8. Now if I have plus or minus in between two fractions and these two fractions have same denominator, then I say the LCM becomes that same number, for example 8. And then I say, for example, if it was plus, I would say 5 plus 3. So answer is 8 upon 8, which is equal to 1. Am I right? But what if the denominators were different? 5 by 8 plus, instead of 3 by 8, let's take 3 by whatever, 7. Now, the LCM in this case will be what? 8 becomes 8 into 7. 7 8s are 56. Now, 7 gets multiplied here with 5. That becomes 7 5s are 35. Plus as it is. 8 gets multiplied here. So 8 3s are, which is 24. So answer is 35 plus 24, which is 59. So answer is 59 upon 56. Understandable? Let's take one last example of LCM. Say I have 5 by 8 plus 3 by 12. In this case, 8 and 12, which are different denominators, I'll check what is the LCM, that means least common multiple. Can I say, if you recall 8's table, so 8 into 3 is 24 and 12 also into 2 is 24. So that means they both have a common multiple. That becomes the LCM. That is 24 becomes the LCM. If 24 becomes the LCM, how did you make 24 using 8? By multiplying it by 3. So when you multiply in the denominator, numerator also needs to be multiplied by same number. So 5 3s are 15. Plus as it is. Again, how do you make 12 into 24? By multiplying it by 2, isn't it? 12 into 2. If you've multiplied in the denominator, numerator also needs to be multiplied. So that becomes 3 into 2, which is 6. Understandable? So denominator here becomes 24, here also 24, so I can write it once 24. And this becomes 15, this becomes 6. So answer is 21 upon 24. Yes, which can be further solved, but you got the point. Right? Based on this, let's begin with the exercise first A. Exercise first A, question number 1 says that you have to add the given rational numbers and show that their addition is also a rational number. Which means the question is trying to ask you, check for the closure property of addition. Isn't it? Let's take the first example. Minus 5 by 8 and 3 by 8. This is the question. So question says I have to first of all show that their addition is a rational number. First of all, are these rational numbers? Check. Yes, this is a rational number, this is a rational number. If you recall in our last video, we've understood what do you exactly mean by rational number. Correct? So these both are rational numbers. I gotta add them. So minus 5 by 8 plus 3 by 8. Now, because it's the same number in the denominator, I'll simply write 8. Minus 5 as it is, plus 3 as it is. So Plus minus is minus. 5 minus 3 is 2. The sign of bigger number, that is minus, upon 8, which can be further solved as 2 1s are and 2 4s are. So it is minus 1 upon 4. Correct? Now, question is asking whether this result that you got is a rational number. What do you say? Think and tell me. Is minus 1 by 4 a rational number? Is it no? Because it is negative? No, 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 no. Answer is it is a rational number. Because if you recall, natural number, whole number, integers, fractions, which are terminating or recurring, all these kinds are called as rational numbers. So I'll call this also as a rational number. Perfect. Now, let's go ahead. Now I'll take question number 4 from the exercise. Why? Because rest of the questions, question 1, 2 and 3 are similar to that we solved just now. So I'll go to question number 4. Question number 4 says, verify commutative property of addition of given rational numbers. Now, first question they are asking is this: minus 8 by 7 and 5 by 14. I have to verify what? I have to verify commutative property of what? Of addition for these numbers. That means, in simple words, I have to first add these numbers. After adding these numbers, whatever is the result, then I'll interchange the position. Then add and see the result. If in both cases the result is same, I'll say yes. Commutative property of addition is true for this set of rational numbers. Okay, let's see. So minus 8 by 7 addition, that means plus 5 by 14. Now, when I solve this, LCM, does 14 appear in 7's table? Yes. So LCM becomes 14. 7 into what gave you 14? 2. If you multiply in the denominator, numerator also needs to be multiplied always by the same number, 2. So what is the answer? This is minus 16 plus 5. Correct? Further, what will be the answer then? 16 plus and minus is minus. 16 minus 5, 11. Greater number sign, minus. So minus upon 14. Am I right? So we got some result. First of all, is this a rational number? Yes, it is a rational number. You can divide it and see it is terminating. Okay. Now, once I got this, I will interchange now. So 5 by 14 plus minus 8 upon 7. That becomes 5 by 14 plus into minus, minus 8 upon 7. LCM again is 14. How did you make 7 into 14? Into 2. So into 2. Now it is 5 minus 16. So 16 minus 5, 11. Greater number sign, minus upon 14. Did we get the same result? Check. Yes. So if we got the same result, I will say commutative property of addition is true for this set of numbers. Got it, everyone? Nice. Obviously, next one we'll talk about associative property. Of addition. Question 5 says, for each set of rational numbers given below, verify the associative property of addition of rational numbers. So first he has given is 1 upon 2, 2 upon 3. Will he give two numbers? No, he must give three numbers, because associative property, if you recall, needs three numbers. Now, first I will group first two numbers, like 1 upon 2 plus 2 upon 3. When I say group, I'll put them in bracket. When this is solved, that answer may say I'll subtract 1 upon 6. Now the fact is, it is addition, so I must write plus and then this minus comes in bracket like this to be clear. Okay, so first I'll have to solve this bracket. Let's begin. LCM of 2 and 3. Now they don't go in each other's tables, or there is no common multiple also, I would say. In that case, LCM, right or not? Let's see. Now, can I say 2 into 3 gives me 6 and 3 into 2 also gives me 6? Correct? So I will say what? I'll multiply here by 3, therefore here by 3, here into 2, therefore here into 2. So the LCM now becomes 6. I'll get here 3 plus 2 into 2 is 4 plus minus 1 by 6 as it is. Next step. 3 plus 4 is 7, 7 upon 6. Plus into minus is minus 1 upon 6. LCM becomes 6. 7 minus 1, which is 6. 6 ones are. So answer is how much? 1. Did you understand this part? Now tell me, what will I do here? I will just change the order. That means first I'll solve these two, and that result will be added to 1 upon 2. Let's see. So it becomes 1 upon 2 plus 2 upon 3 plus minus 1 upon 6. But first, this needs to be solved now. That result will be added with 1 upon 2. This is how we check associative property, by shifting the brackets. First I took these two terms, solved. Here I'm taking these two terms, I'll solve. So this is how we check associative property, right? Let's go ahead. So 1 upon 2 plus 2 upon 3 plus into minus 1 upon 6. 1 upon 2 plus LCM, yes, 3 2s are 6. So the whole upon it becomes 6. But into 2 here to make it 6. Therefore into 2 here also. That becomes 4 minus 1. So 1 upon 2 plus, what is 4 minus 1? 3. 3 upon 6. Can I say I can solve it further? Yes, that becomes 3 1s are, 3 2s are. So I've got 1 upon 2 plus 1 upon 2. 1 upon 2 plus 1 upon 2. LCM becomes 2. 1 plus 1, which is equal to 2 upon 2. And the answer is 1. Did I get here also 1, here also 1? Yes, I got the same answer. So can I say associative property of addition is true? Is true for this set of rational numbers. Correct? Going for the next type of question. Question 6 it says, write additive inverse of minus 3 by 8. Now when question says something like this, find the additive inverse of or write additive inverse of this or any such number, it's very, very simple. Now this is just a difficult or complicated word. Simple word for this is find the negative of this number. But you have to remember this term, additive inverse, which means negative. So you think and tell me minus 3 by 8 ka negative I want. So it is nothing else but minus 3 by 8 ka negative. That becomes minus minus plus 3 by 8. That's my answer. Let me take one more question. So if I've got next question as 4 upon minus 9. And question says write additive inverse of 4 upon minus 9. So look, this minus, let it be here or in the numerator or in between, it is not a matter. Okay, so 4 upon minus 9, additive inverse of this, I can directly write the answer is 4 upon 9, because negative of 4 upon minus 9 is 4 upon 9. But if you want to see the steps, how will I go about it? I'll say 4 upon minus 9 as it is, and then negative sign, which is equal to minus minus again becomes plus, so 4 upon 9 or plus 4 upon 9, one and the same. Let's take one last example. Tell me the additive inverse of minus 2. Obviously the answer is 2. Okay, one more. Tell me the additive inverse of 0. What's the answer? You'll say minus 0. There is no such thing as minus 0 or plus 0. 0 does not have sign. So it is just 0. What is additive inverse of 0? It is always 0. Nothing else. Got it? 0 does not have a sign. What is additive inverse of 1? Additive inverse of 1 is minus 1. Because 1 can have sign. 0 as a number never has sign. Plus or minus doesn't matter for 0. Okay? Now I hope you've understood. But to be clear with things in maths, you just don't have to understand orally. You have to do it and see. Okay? You have to actually practice it so that you be totally clear with it. So I would suggest start exercise 1A today and solve it completely. Yes, all the questions of exercise 1A. Just solve it on a notebook. Make a proper notebook of maths and start solving. Don't worry. Take time. Take time of like 2 days. That's okay. But trust me, the things are very simple. You should do it for practice. Alright? So, we will stop the lecture here. I'll meet you soon.